Hi everyone, this is Dos Muhammad with you. Today I will explain to you about the MPLS Packet Transport Network. Okay, let me just give an overview for this. Okay, what is Packet Transport Network? In Packet Transport Network, okay, currently we are using MPLS and MPLS TP technologies. So the purpose is to connect 2 points of the customer network. Okay, like if I can see here is customer H and customer H. You can see like one end is, let's suppose, any BTS and the other end is any BSC, okay, or it can be E node B, the other side can be RNC, or both ends can be switches. So any of the devices we can connect through our MPLS-TP network. Okay. So what are involved in this packet transport network? We have a link layer. It will be a physical link. Then we have logical pipes, which is called as LSP or a tunnel. Then we have logical services over pseudo wire PW. But PW is a wire which is connecting our services. Okay, so we can map any of the services, like we can map our E1 services, which is through CES, or it can be Ethernet services. So the local services will be encapsulated and it will be mapped into the pseudo wire. And pseudo wire we configure our LSP logical pipe, which is tunnel. And then we have one logical port. It can be uh, any of the universal platform board, or it can be a unique Ethernet line card. And then we have the physical fiber between two nodes. Okay, so this is just an overview. Like in the MPLS TP network, we have these things to be considered, like customer services map into the pseudo wire. Pseudo wire is configured over tunnel or LSPs. Then we have our layer 3 interface towards the line over physical fiber. Okay. This is a practical aspect of the network. Like I have one setup to explain practical network understanding. Okay, here just consider two simple network connection. We have two nodes. One is SAP001 and the second one is SAP002. Or you can say this is two nodes. The product I am using is PTN990E from Huawei, just for understanding. Link layer is 10GE link. Okay. And the network interface, like one of the node slot is 7, port is 1. This is the board, EX4 board. And the other side, we have also slot number 1 and port number 1. Then we have backup link, slot 8, port 1, slot 8, port 1. So this is the network architecture, and it is physically connected like this, okay? The other side will be either GE or AP services, or it can be E1 for the user interface, okay? What are the key parameters that need to be considered? It should be any ID, then is the LSR ID and communication IP. So the planning for this should be like, you should consider this. This is our any ID for one node, for second node, and this is the name. Then we have LSR ID for both. It should be in the same subnet. And we have communication IP. This communication IP will be used to communicate with the NMS NMS server. Okay, and the LSR ID is within the network. Like for if you are configuring internal over this network, so it is considering the NNI IP address and also taking into consider the node learning, like what is my adjacent node. So it should be a unique LSR ID for each node. Okay. And the network interface plane is like we have slot 7 port 1 and slot 8 port 1. So this is for both nodes. Okay. This is just an overview, and let me just show you the practical network overview. So as I explained, the network is that we have two nodes, SEP01 and SEP02, right? And this is our connection, slot 7 of each node, port 1, and slot 8, port 1. So we have two line interface connections. What are the boards I am using here is, I am using EX4S, slot 7 and slot 8. This two board is 10GE processing board with 4 ports, okay, each one. And here I can show you like we have different boards like EM10F. This is 10 port multi-rate GE and FE similar board. We have K2 EM80. This is 8 port GER FE. This is electrical interfaces, and the other one EM10F is the interface is optical interface. We need to install a SFP module. And this board is used to hold the physical interface and processing of T1 services. And we have these two boards in 1+1, which is the control communication. It is used for overall processing and having the cross connect module plus clock processing. So this is like 3-in-1 functions, control and communication, and it is having the packet cross connection module plus clock processing. We have power interface modules and we have PAN. So this two this two node setup is identical, like we have identical two nodes. The other side board interface and board type is the same as the previous node description. So in this network, we have two nodes. The line is connected. Just me give an overview. You can see different through different options the same information. Like I can see this from properties, the node ID, okay, node name, whether it is gateway or non-gateway. So I configure this as a gateway node. It can be non-gateway, then you will need to specify the gateway IP here, but this node is itself a gateway node, okay? And the other node is also defined as a gateway. Okay, you can see the type. It can be SSL or it can be commons. SSL is suggested, it is more secure, but it must be supported by the other side NMS server. Okay, how you can see different options, like you select any node, you can go to the Explorer, and from here you can see different options like device panel. This is the any same information like node ID. We have different options to check for the interfaces, like what are the available Ethernet interfaces and what it is status. Okay, and even we can go into the most our concern part is the MPLS management. Here we can see this is a LSR ID. Okay, so one is the LSR ID. what was another options that is the NNI interface IP. Okay, like if I want to check the network interface IP for MPLS services, so you can see here. Okay, this is the interface, and from layer 3 you can see this is the network line side NNI address. So this subnet should be different from the node LSR ID, but the opposite in NNI IP address should be of the same subnet. Like I am repeating this again. Okay, this is LSR ID 1299.1.1. The opposite node, which is in the same subnet. Okay, you can see the LSR ID for it is 192.129.9.1.2, and here it is dot .1. But if you see this interface IP address, it is a different subnet 129.9.9.1. Okay, and the opposite interface, which is physically connected, subnet should be same. Of course, the IP address will be unique, like it is 2, and here it is 1. So this is the IP address for the line cards, and you can check for the other interface too in a similar way. So over this physical connection, like we have different options. You can see the existing services, existing tunnel configurations, and you can configure new services and new tunnel. Like if I want, here you can see this is for create and this is for view. So let's suppose I want to view the static tunnels. Okay, manage static tunnels, filter all. So this is the existing tunnel configuration, and you can see this is between two nodes, and you have this is the interface for this tunnel and IPs, and this label is automatically taken, or you can manually configure. You can check another tunnel is through the other boards and its interface. Okay, and this can be like protection free, or it can be protected tunnels. Like here you can see it should be working in protection, or it can be protection free. It depends on your planning. So this is the overview of the existing tunnels which are configured, and you can see the existing pseudo wires. Okay, here we have different pseudo wires, and this is also, you can see, a part of the services. Like I configure one E1 services. The alarms under this class is means like currently I don't have connected any services physically, so it will show. So this board with port number 15 and slot 1 port number 15 over these two nodes is configured. Okay, and here you can assign different service name. Okay, like this is for SaaS, and this is the Ethernet services. So here you can see service types also. I will not explain this in a deep detail, but if you open any of these services, you can check its different related, what is the pseudowire ID, okay, and what is the source and sink for it, whether it is having any alarms. Currently, these are alarms because this is just a lab. I did not configure, did not connect any services over it. So this is an overview of this network, how it is connected. This is two products from Huawei. Just overview of the existing tunnels and existing pseudo wires. Hopefully you just understand the basic concept of the packet transport network. In a series of other video, I will explain different aspects of the network. Okay. Have a nice day. Thank you.